do with the 4 addition reactions to a double bond, or alkenes. 4 addition reactions. And I'm going to try to, and I know we got limited time here, but I'm going to try to cover those 4 reactions. I'm going to flip through quickly some slides here that gets us to that topic, but I just at least want you to see them. Maybe on Monday we'll come back to one of these and say, hey, let's draw this molecule. But there's some stuff for you to do. If I go back a slide, draw cis 3 hexene, draw cis 3 trans 3 hexene. All right. So we learned about cis and trans isomers. You need to get real familiar with this, and so draw some molecules based on the name. There's a more complicated one. There's 4 more. Practice, okay? If we can do some of these in class on Monday, we will. But I want to get to this 4 addition reactions. I mentioned that you would see 2 double bonds in the same molecule. This is 2-methyl. This is 2-methyl-1,3-butadiene. Okay, that is the building block that the body uses to start making steroids. It makes steroids out of this. We'll learn this in chapter 17. Reactions involving alkenes and alkynes. Now we're gonna focus on the alkenes here. This is the double bond. Now remember, in chapter 10 we looked at, and you know from the quiz just right now, we looked at halogens reacting with an alkane, and we said it was a substitution reaction. A bromine substitutes for a hydrogen. Hydrogen comes off the molecule. All right. These are, in contrast to that, these are 4 addition reactions. Addition, not substitution, add. We're going to add these molecules to this. And I think I'll try to get it on my computer here, but I'm going to also kind of list it here. So we're talking about 4 addition reactions to alkenes. And there's going to be a lot of similarities to these 4. The difference is, what is it reacting with? In one case, it's going to be reacting with hydrogen. And then it's going to react with a halogen. And then it's going to react with water. And then it's going to react with hydrohalogen. All right? And the names come right off of these things. This reaction is called hydrogenation. All right, you've seen this word already, halogenation. That's what we called it in chapter 10. We talked about the halogenation of an alkane. Well, we're going to now talk about the halogenation of an alkene, but it's going to proceed differently. It's reacting with a halogen. Here the reactant is hydrogen. Here we use X. What's X for? Fluorine, chlorine, bromine, iodine. Any one of those 4 is X. Water. And a hydrohalogen is a hydrogen with a halogen. So what are these? These are HF, HCl, HBr, HI. And this is when a marathon runner is running and they are sweating a whole lot. They need to be, what do they need to be? They are dehydrated. What do they need to be? Hydrated. This is hydration. How do you hydrate a marathon runner? You give them some water. Give them water. Hydration, and this is called hydrohalogenation. All right, now you know what they're called. This is the name of the reaction. This is the type of reaction. It's an addition reaction. And what does that reaction look like? So we're not looking at redox reactions right now. We're looking at addition. Two molecules combine to give one new molecule. I only get one new molecule here. So let me and what I'll do here, I'm going to use this molecule, simple molecule. And we're going to react it with hydrogen. And I'm going to show you how this proceeds. I'm going to try to. All right. We're looking at the first one there. A very simple alkene, ethylene. I've kind of skewed the hydrogens off to the side for a reason. Now remember, this bond right here is 2 electrons being shared between those 2 carbons. And this bond right here is 2 electrons being shared between those 2 hydrogens. So what's going to happen here in this reaction is this electron is going to move up into here, and this electron is going to move up into here. We're going to get a new bond. And this electron is going to move down here, and that electron is going to move down there. We're going to get a new bond. And this bond is gone. Those hydrogens aren't there anymore. And this bond is gone. Those hydrogens aren't there anymore. So what does this molecule end up being? We get that hydrogen right there. Okay, on this slide here it said an addition reaction. This is where 2 molecules react with one another and you get one new molecule. Boom. No more hydrogen, no more ethylene. What did we make? So this is ethene, I've been calling ethylene, which is its common name, plus hydrogen. And what does it produce? What? Ethane. Hydrogenation. It has taken an unsaturated hydrocarbon with a double bond in it and saturated it. Turned it into an alkane. What was that ethene lacking? It was lacking 2 hydrogens. What is hydrogen? It's a diatomic molecule. Half of the molecule goes on the one carbon. The other half of the molecule goes on the other carbon. It turns out that that molecule, each half is identical, right? 2 hydrogens. That's hydrogenation. And they do this to foods. You've seen the words, partially hydrogenated, haven't you? Partially hydrogenated vegetable oil. They did this reaction. Now, the thing I left out is a catalyst. There are catalysts, and 3 of them, 3 different ones to choose from, okay? Probably more than that. But the 3 most common are either platinum, palladium, or nickel. There are certain molecules of these, like chloroplatinic acid, H2PTL6, I don't know, palladium, palladium acid, nickel chloride. Some different salts of these heavy metals will catalyze that reaction. At very low levels, like platinum, you might use at 6 parts per million. 6 parts per million. I mean, just a little pinch, and it catalyzes this reaction. So you do kind of need a catalyst. All right, let's look at this. Halogenation. I'm going to try to get through through these four so you can at least start thinking about it. Let's use our same molecule. Halogenation, so let's pick one. Let's pick fluorine. All right? Okay, now what I want you to see is it's very analogous to what's happening with hydrogen. Again, we've got two electrons right here, and we've got a diatomic fluorine molecule right there. Electron comes up into here, and you get a bond. Electron comes down into here, you get a bond. And so ethene plus fluorine. So when I say fluorine, I write F2. Why? It's a diatomic element. Fluorine comes in, like oxygen, two atoms of fluorine bound to each other. So when these electrons, this bond goes away and that bond goes away, we don't have a double bond anymore. There's our hydrogens. We get a fluorine and a fluorine. And so in this case, it would be like 1,2-difluoroethane. That's it. 1,2-difluoroethane. Okay. Now, I'm going to put a little line right here, and I'm going to say these are symmetrical reactants. What do I mean by that? They're symmetrical. The two sides of the molecule are identical. You see that? We got a hydrogen, a fluorine, a fluorine, a chlorine, a chlorine, a bromine, a bromine. Those are all symmetrical. And in contrast, these are unsymmetrical or non-symmetrical. We're going to see there's implications for recognizing a symmetrical versus an unsymmetrical. So let's go into our unsymmetrical one. Everyone okay so far? Okay, so now let's look at ethene again. We got ethene. Well, let me just point out something. You had a double bond here. You have a single bond now. We got a real simple molecule here, but don't lose sight of the fact that these fluorines, one fluorine each, is going to end up on each one of the carbons that was in the double bond to begin with. Okay? This isn't going to add anywhere else on the molecule, just where that double bond was. That's where you're going to get the two fluorines. The molecule hasn't broken apart or changed its structure because all the time this is going on, that bond is intact. You follow me? This is holding the molecule together the way it started, except we're eliminating one of the two bonds in the double bond. I'll show the implication of that when we go to like propene in just a second. We're going to look at propene. Here's our ethene. Okay, now let me just okay, I'll put it over here so people could see it. This is water. I could write water this way, HOH. This water, sometimes we write it like this. I could write this like this. Okay? I'm going to write it like that. Just know, what do we got here? We got an oxygen-hydrogen bond. Here we got a hydrogen-oxygen bond. It's just like that bond over there. But why am I writing it like that? Because I want to depict my water like this. There's my water. All right? Half of the water molecule is a hydrogen. The other half of it is an OH. You with me? It wouldn't be any problem to write it like that. I just want to let you see that what's going to be involved is either one of those hydrogen-oxygen bonds is what's going to get involved in this reaction. Just like with hydrogen, we're going to get an electron move up there. That electron's going to move up there, and we're going to get a carbon-oxygen bond. And this is going to come down here, and that's going to come down here, and we're going to get a carbon-hydrogen bond. So this is going to become this. All right? Water, H2O, hydration. It's an unsymmetrical, non-symmetrical reactant. When we break one of the bonds, we get a hydrogen in one case and an OH in the other. We don't get the same thing on each carbon because the molecule isn't symmetrical. This is an alcohol. This is chapter 12. We've just introduced chapter 12. You got an OH group on a carbon and you have an alcohol. And so this plus water forms ethanol. Ethanol. And you just got introduced to the the suffix that refers to alcohols. We're taking the OL on the end of the word alcohol and we're adding it to the name, just dropping the E and adding an OL, and we got ethanol. Don't worry too much about naming your products in your chapter 11 homework. We haven't introduced how to name alcohols yet. So, but know how they react. What's formed when water reacts with it. All right, now I only have 5 minutes, so I want to go into, I'll come back to this one in just a second. Let's stick with this one for a second. Let's go to a more complicated molecule. Not very much more complicated. We're just going to add one carbon. Propene. And let's take a look at, there are two possible products. In this case, there's only one possible product. Okay, can you see that if I put the OH down here and the H up there, I'd still have an OH on the first carbon and a hydrogen on the second carbon. Here I got an OH on the first carbon, hydrogen on the second carbon. So, I mean, that molecule and this molecule are identical molecules. You with me? Those are superimposable molecules. So with ethane, it doesn't matter which carbon the hydrogen went on, which one the OH went on. I get ethanol. Ethanol. Now, let's take a look at propene. There's propene, and I come along here, and so I come along here with my water. I could come along with my water like that. Or I could come along with my water like this. And what happens? This one is going to give me, I should have made a little bit more room here. This one is going to give me an OH right here. Hydrogen, hydrogen, carbon, hydrogen, hydrogen, and my methyl group. And this one is going to give me hydrogens on all three of these, 3 hydrogens on that carbon. And I'm going to get my OH down here. Okay? So here's product one, or one of the products, and here's the other product. Do you see those are two different products? They're both propanol. Propane, take off the E, add an O, propanol. But this one is 1-propanol. That's the IUPAC name of that one. This one is 2-propanol. They are not superimposable. You agree with me? They're not superimposable. Those are two different alcohols. They have different properties. They react to form different products. Two distinctly different molecules. Okay, I think 1 minute is kind of long, a short period of time to introduce this, but let me just introduce it real quickly. So this fascinated people. What do you get when you react water with propene? What do you get? And there was a guy back in the late 1800s, I believe it was, Markovnikov, and he was very fascinated with that. He said, well, let's see. Do we get 50% this and 50% that? So he went in and looked at it, and no. You get about 10% this and 90% that. The vast majority of it is 2-propanol. All right, let's just leave that. You're going to see, wait a second, let me just tell you on your chapter 11 homework. Number 3, you can do all of the first page, front and back. I think you should be able to cover all that. You should be able to do 3-1 and 3-1, 3-2. 3-3 and 3-4. Talks about drawing the major product. You don't know that. You need to understand Markovnikov's work and Markovnikov's rule. So I'm not sure you can't do all of 3. You might want to wait on this one. Don't just take a wild guess. Wait until you know Markovnikov's rule and apply it. Okay? And that's where we'll pick up Monday. And then we'll start chapter 12 Monday. We'll definitely have to get into chapter 12 if we want to meet this schedule, and which we do.